All right, so for this optical illusion question that we have here, here's the picture and the family of curves x times y equals c that produces the curved portions of this picture. And the question we have to answer here is find the value of dy over dx for the given values of x and y. So basically what we're going to do here is apply the technique of implicit differentiation in order to generate a relationship involving dy over dx. And then from there, we'll substitute in the appropriate values to find that value of dy over dx for these particular values of x and y. So let's start by just rewriting the equation down. So technically we could solve this for y and then differentiate, but I'm going to do this implicitly because it's usually where this type of problem comes up. So again, we're going to implicitly differentiate, which means we need to differentiate both sides of this equation here with respect to x in this case, since we're looking for dy over dx. So the way I notate it for my students is like this. And then on the left-hand side, since we have a product, we're going to have to use the product rule to take the derivative. So there are two factors in the products. We'll take the derivative of the first factor, x, with respect to x, which is just going to be 1, and then multiply by the second factor. And then I'm going to differentiate, or add to that, by differentiating the second factor with respect to x, which is just going to be y prime, or you can write it as dy over dx. Since the question asks for it, in that way I'll write it as dy over dx. And then multiply that times the first factor. And then we have to differentiate the right-hand side. Now, for any particular value of c is a constant in this case, and we should know that the derivative of a constant is 0. So this is the equation that we end up with that involves dy over dx. Now again, all we have to do is find dy over dx for these particular values over here, and the values were that x equals 1 and y equals 4. The fact that they gave you c equals 4 is irrelevant because c was a constant, and so it doesn't end up in our relationship involving dy over dx anyway. So now I just got to plug in 4 for y and 1 for x. Yeah, just double checking that. So 1 times 4 plus dy over dx. I said 1 times 4 and I wrote y. Oh, go figure that. So it should have been 1 times 4 plus dy over dx times 1, and that still has to equal 0. And then that's an ugly looking 4, so then just dy over dx. Sorry, I'm using my finger for this here and instead of a normal stylus that I would use, so it looks a little sloppier than usual. So then that's just going to be negative 4 when I subtract that 4 from both sides. So that's it for that question and all these types of questions. For the other parts of that section, just implicitly differentiate both sides with respect to x. You can simplify and solve for dy over dx first, but I always encourage my students when they give you particular values of x and y just to go ahead and substitute those values in before doing the algebra, and then simplify the numerical calculations and then solve for dy over dx. To me, and from what I've seen from students, that seems to be students are less likely to make mistakes if they do it that way. So hopefully that helps.